Hello, I welcome you all in this presentation related with the subject fundamentals of surface engineering. And you know that so far we have talked about the various aspects related with the surface engineering, like the fundamental mechanisms causing the wear of the material from the functional surfaces. And then we have talked about the various methods which are used for modifying the surface properties so that the improvement in tribological life can be made. And under this we have talked about the methods wherein just surface metallurgy was modified for improving the wear behavior, and thereafter we have also talked about the methods which were associated with the changing the chemical composition of the surfaces to improve the properties. And thereafter third category of the methods were talked about, wherein we have discussed about the methods wherein a layer of the required material is deposited onto the surface so that the improvement in wear resistance can be made for enhancing the tribological life of the component. So once the surface modification is over for improving the tribological life of the components, it is important to assess really how much improvement has been made. And we do not really assess just the tribological property improvement, but we will also see that whatever properties and the characteristics that can affect the wear behavior must be investigated systematically, and these must be standardized or stabilized so that the process can be applied in very controlled way for using the surface modification at the production level. You know that the performance of any component under the tribological conditions, performance of a component under tribological conditions is influenced by the various group of the properties which includes like those which are associated with the material or the modified surfaces itself. For example, chemical properties, primarily chemical composition of the material, and then for a given chemical composition what kind of the metallurgical properties it has. So like the phase and the grain structure of the material, then we have to see for what kind of the mechanical properties it has. Primarily these include like hardness, or in case of the coatings it may be coating, substrate, bond strength. Apart from and a combination of the mechanical properties will be leading to the given set of the tribological properties, which will be determining or dictating the life of the component under the tribological conditions. So the tribological properties of the material, which we measure in terms of like say wear resistance or the wear rate under the adhesive wear conditions, abrasive wear conditions, erosive wear conditions, or corrosion as per the need of the given application. So the performance of a component under the tribological conditions, whether it is modified or the not or before modification, that will be influenced by these characteristics. So it is important that whatever the properties are there of the substrate or after the modification, whatever we have realized, they are understood well so that we can achieve the expected resistance to wear for a given set of the conditions. So obviously it will be important to investigate the chemical composition, metallurgical properties, mechanical properties, and the tribological properties for a given set of the wear conditions. Apart from the properties for a given modified surface, certain another aspect means there is another aspect that affects the performance of tribological component, which is like say soundness of the modified surface. Means how sound the modified surface is, means it should be free from defects and discontinuities. We know that whether it is the laser hardening or induction hardening, carburizing, nitriding, or the flame spraying, weld surfacing, the different categories of the surface modification techniques, these will be prone to have the defects, maybe in form of cracks, pores, inclusions, as per the nature of the process which is being used for surface modification of the component. Then there are, like say, another kind of the properties that also affect the tribological performance of the component, and that is about the dimensional properties. Among the dimensional properties, like say the surface roughness, indicating the extent of the ups and downs, peaks and valleys present at the surface, primarily quantified using the RA, surface roughness parameter. And another one which also determines the performance of the modified surfaces significantly is the thickness or depth of the modified region or modified zone of the substrate. Like in some of the cases, the modified zone is of very few micrometers, like 5 micrometer, 10 micrometer, or even 1 micrometer. In some of the cases, the modified zone may be further thicker, like PVD, CVD will be offering like 1 or 2 or 5 micrometer modified zone. But there can be the weld surfacing processes which may be offering the modified zone of thickness like 1000 to 1500 micrometers. So, depending upon the process, the thickness or the depth of the modified zone can vary significantly. Since this modified zone significantly determines the capability to sustain under the external load conditions. So, if the load or the stress conditions are very light, then maybe very thin coatings will be okay, but if the load magnitude to load to be taken by the component is very heavy, then obviously the modified zone thickness must be high enough. So, it is important that the surface roughness and the thickness of the modified zone is characterized, because it will also be dictating or determining the resistance of the modified zone against the wear. We always want that wear of the material is as less as possible, and that in turn will be determined by all these set of the properties. So, whatever is the modified surface, like substrate component whose surface has been modified either using one of the processes where in just the surface metallurgy has been changed, or surface composition has been modified, or a layer of the material has been deposited using any suitable process. So, these are the three approaches. Whatever the modification has been applied for enhancing the tribological life of the component, we need to characterize the surfaces for those set of the properties. As I have said, we need to see chemical composition. So, chemistry of the surface is to be determined. Since the chemical composition directly affects the various phases and the various size of the micro constituents which will be present at the surface, and these in turn will be governing the mechanical properties like hardness, toughness, bond strength, etc., and these in turn will be governing the resistance to wear. So, obviously there is a sequential relationship between these set of the properties. We need to, therefore, we need to assess the chemical, metallurgical, mechanical and then tribological properties of the modified surfaces. What we realize through this characterization, that is what we have to see. So, why do we need at all a characterization of the modified surface? So, purposes of the surface characterization or characterization of the modified surface. So, there are, we can say there are three important dimensions or aspects related with this characterization of the modified surface. One is the quantification of the properties, given properties, which may be in terms of like composition, it may be in terms of the kind of microstructure and the grain sizes it has, the kind of hardness it has, the kind of roughness it has, what is the modified thickness of the modified layer. So, all these properties are characterized, and based on this we can really take a suitable decision whether the modified surface is suitable or suitable for given set of application. So, basically we try to assess the acceptability of the modified or engineered surfaces for a given application, whether after the modification it will help us to realize the required goal of improving the tribological life or not. So, suitability of the modified surfaces for a given set of application is assessed after the quantification of these properties. So, we know what are the values of the various properties and whether it will be suitable for a given set of the or for given application or not. There is one more dimension to this that is about, it also helps us to study the effect of the service conditions. Once the modified surface has been exposed to the surface service, then under the service how it has been performing, that is also to be assessed. So, to study the effect of the service conditions during application of the modified surfaces. And what we basically can observe, like if the component has been exposed, modified surface has been exposed to the high temperature for longer period, there can be loss of alloying elements, which will be leading to the modification of the chemical composition of the near surface layers. There can be enrichment of the alloying elements also. So, this can be leading to the embrittlement of the modified surfaces due to the enrichment, like say the carburizing is one typical example of this. Then there can be change in microstructure due to the prolonged exposure at a higher temperature. Change in structure can take place, which may appear in form of like say coarsening or destabilization of the certain phases. Prolonged exposure at a higher temperature may lead to the decomposition and destabilization of the certain phases, leading to the formation of the softer phases, and like say the spheroidization in steels is one typical example of this, graphitization is another, and then formation of the chromium carbide in chromium molybdenum steels and austenitic stainless steel is the another example, wherein modified surfaces at a high temperature are adversely affected due to the change in undesirable change in the microstructure of the material. Then since the structure has been modified, so obviously after the service it will be leading to the change in the surface mechanical properties of the surface, which may appear in form of increase in hardness or decrease in hardness. Increase in hardness can take place especially if like this surface has been subjected to the carburizing or the work hardening, or Similar kind of the effects where structural modification is leading to the change in surface properties. There can be the reduction in hardness as well if there has been destabilization of the microstructure micro constituents which were contributing to the required hardness, or there can be the loss of the alloying elements from the surfaces leading to the reduction in hardness. So, the chemical composition modification or the microstructural modification, this can lead to both the hardening or softening. In addition to that, hardening can also occur in case of the work hardening if the surface layers are being deformed due to the external stresses during the service, then it will be leading to the work hardening of the surface, and that will be changing the surface properties. Any change which is leading to the variation in properties in terms of increase in hardness or decrease in hardness, in terms of the chemical composition like loss of alloying elements or increase in concentration of the certain alloying elements, or coarsening of the grain size, like grain size is being coarsened, or the phases being destabilized. So, the metallurgical properties are getting modified due to the exposure during the service conditions. So, all these undesirable changes can be leading to the reduced wear resistance, and once the wear resistance is reduced for a given type of the service conditions, then it will be reducing the tribological life of the component for those service conditions. So, these are the various purposes and the various aspects that will be leading to the need for effective characterization of the modified surfaces. So, we will be starting the surface characterization characterization or characterization of the modified surfaces for assessing their suitability. So, with regard to this, we will be taking up first of all the dimensional properties. Among the dimensional properties, basically there are two aspects about which we will be talking. One is the depth oblique thickness of modified zone, and the second one is about the surface roughness, that is RA. Since we use since the surface modification techniques vary or change significantly, their approach is different. The basic principles applied for modifying the surfaces are different, and that is why the kind of the thickness of the modified zone and surface roughness vary significantly, or they change significantly with the change of the modification process. For example, if we take the category 1 process where just surface metallurgy was used for modifying the surface properties, under that we had like laser hardening, induction hardening, flame hardening, electron beam hardening. So, in these methods there was so these were the cases where the heat was used for hardening purpose. In this case, we have to just heat it to the austenitic state and followed by the rapid cooling. So, there is no dimensional change as such, just the surface the phases present at the surface layers are modified for improving the properties. So, there is no reason for variation in the surface roughness in this approach after the hardening, except that due to the heating, if some oxidation is taking place, so that will be increasing the Ra value. Otherwise, mechanically the surface properties with regard to the presence of surface irregularities, surface properties are not modified, except whatever change in the surface roughness will be taking place, that will be happening primarily due to the surface oxidation. Then there is another group of the processes under this, that is where we use the mechanical stresses, for example in burnishing, then shot peening and contour rolling. So, in all these cases what we see basically, the surface layers are intentionally deformed to achieve the required work hardening effect, so that the enhancement in surface properties can be achieved. So, definitely when these methods are applied, the kind of the ups and downs present at the surface, those characteristics are modified. So, there is always change in Ra value of the surfaces modified using burnishing, shot peening or the contour ruling. Then we have the second category of the methods where chemistry of the surface is modified, chemical composition of the surface is modified. So, wherever diffusion is used by putting the component at a high temperature, due to the oxidation there is a possibility for change in the surface roughness. While there is another kind of the approach. So, diffusion can happen like at high temperature, like in processes carburizing, nitriding, etc. So, the chances for the change in Ra is very less. So, no change in Ra, but if at the surface layers like some kind of the shoot formation is taking place due to the deposition of the carbon or some kind of the oxidation is taking place, then that will be leading to the minor increase in the surface roughness value. There is a third method where a layer of the required material is deposited onto the surface by various processes, for example welding for weld surfacing or thermal spraying, and then electroless plating or electroplating, or electroless plating. So, in all these methods where wherever either the complete complete melting or the partial melting is taking place, there will be the possibility for the greater roughnesses, and whatever is the roughness of the substrate in the beginning, based on the approach of the surface modification, whether it is the weld surfacing or thermal spraying or electroplating or electroless plating, all these methods will be offering the different roughness values, and which can vary significantly from like say the 1500 micrometer to the very less value like 10 to 15 micrometers. So, based on the process being used for surface modification, there can be large variation in the surface roughness values. So, it is important considering the application of the modified surfaces, it is important that surface roughness is characterized and modified accordingly as per using the suitable secondary processes like machining, grinding or other surface finishing processes, so that the required improvement in surface roughness, required reduction in the surface roughness can be achieved, so that the component after the surface modification can be used for a given application. Surface roughness which is primarily measured, roughness is primarily measured using a parameter, the Ra, which is also known as the center line average value. It is about like if there are certain peaks and values present at the surface. So, with reference to one imaginary center line, average height and depth of these peaks and valleys is taken into the consideration for measuring the surface roughness. This is one of the most commonly used parameters for measuring the surface roughness in India. Roughness is important because roughness measurement is important because of the certain regions, like the kind of the unevenness which is present at the surface, that will be dictating the kind of bonding which will be there when it mats or comes in contact with the another matting component. So, if the roughness is high, then the interaction or the kind of bonding between the peaks and valleys at the matting interface is too much, and that will be leading to the increased friction. So, higher roughness will be leading to the higher friction, and similarly the wear rate is also increased. So, increase in the RA value will be increasing the roughness as well as the wear rate. So, in order to reduce the wear, in order to reduce the friction coefficient, it is required that modified surfaces are of the lower values as lower as possible, or if these are not of the required values, then suitable surface modification technique is applied so that the required roughness can be achieved. Apart from affecting the friction and the wear behavior, the surface roughness, especially the valleys present at the surface, acts as a point of the stress concentration, and which facilitates easy crack, nucleation and growth, primarily due to the higher stress concentration. And therefore, under the tensile stresses, if the surface roughness is more, then it promotes the stress corrosion cracking. At the same time, higher stress concentration due to the deeper valleys, especially these promote these lower the tensile strength as well as the fatigue resistance of the component. So, in order to enhance the fatigue resistance, in order to enhance the tensile strength and reduce the stress corrosion cracking tendency, reduce the wear and reduce the friction coefficient, it is important that surface roughness is as lower as possible. So, there are two categories of the methods which are used for measuring the surface roughness. About that I will be talking in the next presentation. So, now here I will summarize this presentation. In this presentation, basically I have talked about the need of the characterization of the modified surfaces, and how it is how the characterization can help in taking the informed decision about the suitability or use of the modified surfaces for given set of the applications. Thank you for your attention.